crisp and clear triangles. Three-sided polygons. An important fact to remember of a triangle is that, okay, its angles must equal 180 degrees. That means this: if I have a right triangle and I know that this is 30 degrees, I can figure out what that angle has to be, because I know that when I add the three angles of a triangle together, it has to be 180 degrees. A right angle is 90 degrees. I know I've got a 30-degree angle. That's a total of 120 degrees. What angle, how many degrees would this have to be to give me my 180-degree total? It would have to be 60 degrees. I suppose the other thing we should talk about is this. I wish I actually had. Well, maybe I do. Maybe I don't. The book will ask you a question, and people struggle with this, so let's talk about it now. Can the three sides of a triangle be 2, 3, and 6 inches? Could I have a triangle that's 2 inches on one side, 3 inches on the other side, and 6 inches on the third side? Yes and or no? Let's see if we can do this here. I'm going to do a line. Let's try this. How long would 2 inches be, would you say? And can I double? I'm going to double both of them just to show you. Let's say I've got 4 inches, about that. Sure, why not, right? And let's say I have 6 inches, which is about that. Oh wait, no, yeah. Let's say that's 6 inches. And then let's say my third side is 12 inches. How long would 12 inches be? About there.
Can't you move further?
No.
Now, I can move these and adjust these. In other words, I could take this. Oops, sorry. I could take this. Why does it do that? I could take this and bend it down like this. And take this and bend it down like this. And I suppose that's not a good example there. The question is, and my things are off here, could this be 4 inches and this be 6 inches, and could this be 12 inches? Yes or no? Gary?
Yes.
It could. Now, let's say I turned this as far as it could be down. If I add these two lines together, how long would they be? 10 inches, right? So if I put my 4 inches here and laid my 6 inches here, okay, how long would my 12-inch line be compared to that? My 12 inches would be 2 inches longer than that, right? So here's the deal. I can't take this. If I move this line over here and touch it with this corner, and I move this line over here and touch it with this corner, is there a way I could swing it so that those two lines are ever going to meet? All right. You're going to make me do this here. Scissors, my kingdom for a scissors. Let's do this. Maybe this, anybody know the size of a piece of paper? And this is completely, paper is 8.5 by 11. Okay? Here is, well, here's an 8, and I'm going to make it this. I'm going to take a 1/2 inch off of this piece, right? So now this is how long? Christian, write 8 inches on that, because we know that's 8 inches. That was about an inch long, so this paper now no longer is 11 inches wide. It's probably like how long from here to here? Take an inch off of 11 inches. This is probably 10 inches. Does anybody actually have a ruler here? A real long ruler? All right. I want you actually to measure this. I need a witness here. This is 10 inches, right? 10 inches on it. This is 8 inches. Where I know this is 8 inches. Okay. If these are the two sides of my triangle, people, okay, here's my two sides of two of the sides of the triangle. What is the absolute longest that my third side could be? Because see what happens is this, as I start spreading these things out, I could make that third side as short as I want because I can keep pulling these in and in and in until they're almost touching. But that third side, when I start spreading this out as wide as it humanly possibly can be, the widest I can go, well, if it's a straight line, the longest that third side could be is 8 plus 10 inches, 18. I cannot get a third side that's longer than 18 because this is as long as it's going to go. To get to the two corners to touch a 20-inch line, I'd have to spread them apart like this and leave them flat, and they would never touch. Okay, so when you have two sides of a triangle, the longest the third side could be would be those two sides added up together. And it couldn't be those two sides added up together because the only way to get it that long would be for this to be a completely flat line. Okay, so the longest that the third side could be would be just a hair shorter than 18 inches. Because if it's longer than 18 inches, these two sides will never make a triangle because it ends up being a flat line. Now you can make it, like I said, as short as you want because as you keep coming in like this line keeps, actually there is a rule that the shortest it can be too. The shortest it can even be about 2 inches because that would make another straight line that way. So the question is this, could you have a 2 and a 3 and a 6 is no, because if you have a 2 and a 3, the longest that next line could be would be 5 inches. There's no way you can have a third side bigger than the other two combined. Because two of the sides of the triangle laid flat to each other are as long as they're going to get. I don't think. Could you have a 2, 3, 6? No. So does that kind of make sense? The book will ask you questions to think about, and it's kind of hard to do it. Maybe you can go home and make triangles and see if you can figure it out, because you really can't do it unless you experiment with it yourself. Christine?
Where are we going to learn to do the area of the triangle?
Oh, when we get to areas of triangles. That's coming up soon. But that's neither here nor there. Still under triangles. Still under triangles. Write this one down here. We classify triangles in two different ways. And this is what really is important here. We either classify triangles by their angles, or we classify triangles by their sides. And we have 3 of each. Okay. If a triangle has a right angle in it, little square corner there, it has a special name. I don't know why they call it this, but they call it a right triangle. A right triangle has one right angle. A triangle can't have 2 right angles because you'd have used up all your 180 degrees and 2 angles, nothing left. Got that? We can have a triangle that has all acute angles in it. All angles less than 90 degrees, that's called a acute triangle. Oh wait, yeah. And what's the third one we can have? Anybody know? We can have one right angle, we can have all acute angles, or the last one would be, yeah, it has one obtuse angle in it. Something like this. The other 2 have to be acute, by the way. It's not an acute triangle unless they're all 3 acute angles. This one is called an obtuse triangle because it's got one obtuse angle in it. That's one obtuse angle. Obtuse. Okay, so you need to have that down in your notes because I'll ask you, and make sure you look in your notes. I'll say classify this by its angles. These are your only choices. If you classify by its sides, you can have three different things. You can have all sides are equal. We showed that by doing that. If all sides are equal, it's called a equilateral triangle. You can have just two equal sides. And again, you put those little slash marks in it, that shows it. Two equal sides is called, Gary, an isosceles triangle. Isosceles. It has two equal sides. And then you have a triangle that has no equal sides. No equal sides is scalene triangle. No equal sides. All right, Christine, are you ready then? The area of a triangle. No, you can put it on the triangles. It's up to you. Wherever you think you look at an area. Does anybody remember the formula for the area of a triangle, Christine?
Area equals 1/2 base times height.
1/2 of the base times the height. Now, with that being said, what special thing do we know about the base and the height? How do we know what's the base and what's the height of a triangle? One simple little rule that sometimes we forget. Gary?
The base is the bottom.
It is not always the bottom.
Oh, the longest.
Not always the longest. Not always the shortest. The base and the height have to, Christine?
Form right angles.
Yes, they must form right angles with each other. Okay? In other words, if I have a triangle that looks like this, and I know that this is 10 inches, oh, let's say this is 10 inches, and this is 10 inches, and I know my formula is area equals 1/2, by the way we abbreviate it, B and H. What is the base? What two lines form the base and the height there? What two lines form the base and the height there? Ryan? What's that? Exactly. None of these form right angles. You can't tell me the area of this triangle here. If they give you a triangle like this, they have to, the book will have to give you a dashed line that does form a right angle, and they'll have to tell you what that line is. Maybe that line is, I don't know, 8. Then, once you know the two lines that form the right angle, you can plug it into this formula. Area equals 1/2 of 8 times 10. And I need to see this, children. You give me formula, you give me it filled in. You know, after that, if it's something easy like this, you could do, area equals 8 times 10 is 80, and 1/2 of 80 is 40 inches squared. Okay, they have to form right angles. Now sometimes it'll look like this. If this is your triangle, and you know that this is 12 inches, and this is 8 inches, and this is 10 inches, again, you can't, did I do something wrong there?
No, I'm just so confused.
You want me to go back to that screen?
No, he explained.
Okay, if this is the case here, they might do this, might shoot a line straight down like this, and then shoot a line over like this and give you the right angle there. Okay, and then they'll have to tell you what this is, maybe that's 7 inches. Okay, so you would use this line and this line, so it's 12 times 7. Area equals 1/2 base times height, area equals 1/2 7 times 12. And it doesn't matter which one you call the base, which one you call the height, it's going to be the same. Half of 12 is 6, and 6 times 7 is 42. Let's use the square. Stop me there if you don't quite comprehend that move. Perfect.